All right, well, welcome everyone to the slightly delayed September Elixir meetup, which is happening on October 1st.
Sorry.
I'm really glad that we delayed it. I was in no way prepared for 2 weeks ago, so this is great. But before I start, I want to give a couple shout outs, because this isn't like just me doing this. Surprise, surprise, there's other people helping us. Kevin and RBC give us the space, which is amazing. So big round of applause. Grigori's helping us out filming, so now we can upload these talks to YouTube, which is also phenomenal.
Next level professional.
Very professional. And Jeff and his company Quorum Software, who help sponsor 2 of these. So my company sponsors 4, but we do 6 of these a year and we need more money, and Jeff just made it happen. So all the pizza that we're enjoying tonight and all the beers that we're drinking, that's this guy. So if it wasn't for that, we wouldn't be here. So sorry to put you on the spot, but you kind of made this one happen, so thank you.
Just to be clear, my company, the company I work for, Quorum Software.
You could claim that you own it, and no one would argue. So yeah, with that, why don't we get started? So my talk today is an intro to GenServers, and this is a word that we've kind of like thrown around in the past. Kevin's kind of mentioned GenServers and tasks and processes in some of his intro to Elixir talks, but I don't think we've ever actually like seen how they work. So I think today we'll spend a couple minutes going through them, and I can show you guys like what a GenServer is and how it works and what it can be used for. And then next time we'll actually like use them to build something cool and interesting so we can see them like actually in action. So why don't we jump in and learn what is a GenServer? So according to HexDocs, which is kind of like the Elixir documentation repository, a GenServer is a process like any other Elixir process. It can be used to keep state. We can execute code asynchronously, and so on. It does a lot of things. And the advantage of using a GenServer process is that it will have a standard set of interface functions. So what that means is it exposes to the developer an API that you use and interact with. And once you've implemented one GenServer, you've implemented them all. And the nice thing about this is it kind of abstracts the way of managing a process and managing process state and how it's going to interact with your application. It takes that away from you, and so you just have to focus on coding the happy path. But before we get into that, we need to figure out what a process is. So we're going to go back to HexDocs, and we're going to learn that in Elixir, all code runs in processes. So a process is like the atomic piece of work in Elixir. They're isolated from each other, they run concurrently to one another, and they communicate to each other via message passing. These are not only the basis for concurrency in Elixir, but this provides the means for building distributed and fault-tolerant programs. So this is what makes Elixir great for all the things we've talked about in the previous discussions. So processes, they're spawned, they do some work, and then they die. Meaning once they finished what they need to do, the scheduler takes back that memory and uses it for something else. So we can see that in action here. I've got a very simple process. We start it with this spawn function, and it's given an anonymous function, and it's going to print out hello from the process. Very simple. There we go. We got hello from the process. Now the function spawn returns a PID, or a process identifier, and this is the value that we can use when we need to communicate with the process. So one thing that we can do is we can ask if the process is alive. And since we've learned that once a process has done its task, it's dead and returned to the memory pool, we probably should receive false. So the process is not alive anymore. But what if we want to keep the process alive, right? What if we want this thing to maintain some state? What if we want this thing to communicate with other processes or live for longer than just enough to execute one piece of code? We need to give it a recurring or recursive task. So for example, we can do something like make it listen for messages. And this might look familiar because this is something that Kevin's kind of demoed in the past. So let's look at this module, which spawns a process, and it listens for incoming messages. That's really all it does. So we've got this public function that we're exposing here, start link. This is how we spawn the process. And then from start link, we call the loop function, which continuously calls this receive block and then calls itself after it gets a message. So this receive block is going to match on a input, which is a tuple, atom print as the first element, and then a message, and then it's going to print the message. If you give it something it doesn't understand, it's just going to go what? and then go back to the loop. So we're continuously listening for more messages. And this is how we can keep a process alive. We can give it some work to keep doing. So we'll compile this module. All good. And now let's run this code snippet. So we're going to extract the PID, and we're going to send this process a message to print. We're going to send it something else. So we expect it to print this message and then print what, because it doesn't know what to do. And then we'll put it to sleep for a little bit, and we'll ask if it's alive again. And hopefully it is. And there it is. Process alive, true. So this is how we can keep processes alive, is we can give them a recursive task to keep evaluating. So now, can a process be used to store state? I'm glad you asked, because it absolutely can be used to store state. All you need to do is pass an initial state into this loop function, and then pass that argument around through recursion. So if you pass its state over and over again, it's always going to have that state in the next recursive loop. And this is how we can use a process to store data. So now I've got a module here which is going to do something similar to the one before. We've got this loop function, but to loop we're going to pass an empty list. And we are going to listen for messages here. We're going to listen to put and pop messages. So put, we're going to take an item, we're going to add it to the head of the list, and then we're going to loop back with this updated list. Same thing with pop. Well, not same, slightly different. We're going to pop an item off the head of the list. We're going to send it back to the caller, and then we're going to loop with that updated list, meaning the previous list minus the element from its head. So this is how we can store state in a task, is if we just keep passing a value back and forth as we recurse. So we're going to do the same thing we did before. We'll start a link to the process. We're going to bind its PID to a variable called PID. We'll put a couple items in the list, and then we're going to ask if it's alive, just to make sure that it is. We're going to grab an item off the top of the head of the list, and then we are going to flush our process as a message box to see that we've got that item back. So let's run this code. So we put the first item in, we put the second item in, waited a second, checked if the process is alive, and then we've flushed that second item off the head of the list back from our mailbox. So this is how we can communicate with processes. We can ask them for things, we can ask them to store things, just as long as we pass that variable back and forth through that recursive loop. So this is all cool, but I think the title of this talk kind of alludes to where we're going. We're going to see a better way to do all of this, and we're going to do it with a GenServer. Because like I said, the GenServer kind of abstracts away all of this from us. We don't need to figure out how to store the state. We don't need to manage all this recursion. All we need to do is implement a GenServer behavior, which is going to remove a lot of this boilerplate and give us as developers the ability to just focus on what do we need this process to do instead of how do I keep this process alive and how do I communicate with it. So the main functions we're going to be looking at today, exposed by the GenServer behavior, are init, handle call, and handle cast. So init is invoked when the server is started and handles start link messages, kind of like we've been doing before. And this is going to block the process until the function returns. So as you're starting up your GenServer, this is going to be a blocking call. Once it's ready to go, you can keep going. Handle call is going to be used to handle synchronous or blocking call messages to the server. And handle cast is going to handle asynchronous or non-blocking messages to the GenServer. Now, the way that I remember these, it's kind of a silly mnemonic, but call and cast, I think of like making a phone call. I have to wait for someone to pick up the other end. It's a blocking process. Cast is like I'm going fishing. I can just cast a line and then go do something else while I wait for the fish to bite. It's not blocking. I mean, I could also put the phone down and walk away while I wait for someone to answer, but then my mnemonic device would fall apart. So I'm going to stick with this. So let's pop over to VS Code and we'll see some examples of this. So I've got two little demo GenServers here to show you guys. I've got a calculator, which actually in the hex docs tells you is a very bad implementation of a GenServer. But I think for the processes of showing how it works, it's a pretty good one, but like you would never want to do something like this in production. So we've got our GenServer functions here at the bottom. We've got init, which has to return a tuple of OK and an initial state or an initial value. We've got handle call, and this is going to handle our blocking messages. Very simple. We're just going to be adding and subtracting values. So we're going to use handle call for subtract as well. Very simple, very easy peasy. And then here at the top for our public API, we've got start link, add and subtract. So this way, Processes calling this calculator gen server, they don't need to understand the implementation here. All they need to know is there's a function called add, and it takes a PID and a number, and it adds that to the state of the gen server. So we'll start an IEX process, and we'll start communicating with this thing. So we can go OK PID. Oops. Maybe if I could type a public setting, that would help. So let's go OK PID. And that is going to be our simple calculator gen server dot start link. And we can start with an initial value. We can pass it 1, or we can default to 0. I think let's just default to 0. And great, we've got our PID. So we can go process.alive, and we can see if our gen server is alive. And it is. So now we can just start adding things. So here is our public functions, add PID number. So let's go simple calculator dot add. We'll add 10. So we've got 10. If we do that again, we should get 20. And if we go subtract, let's say subtract 5, we should get 25 back. So very simple implementation of a gen server here. We've got this thing holding a state, and we can update that state by adding and subtracting to it. So handle call needs to return a 3-arity tuple, reply, and then 2 values here. The first value is what we give back to the caller. The second value here is what we give back to the gen server process. But in this case, they're the same thing. It's just the updated numerical value that we're storing. So now if we go to the demo gen server, we can see how call and cast behave a little differently. So I've got 2 functions here. I've got handle call, which is going to handle call messages. Same thing for cast. Call is going to be a blocking operation that's going to block the process for 2 seconds. Cast is going to be a non-blocking operation, but it's going to take 4.5 seconds to complete. And after 4.5 seconds, we should see a message called cast done. So we can start a gen server again for this. Demo gen server, let's start link. So we've got this PID. So if I go demo gen server dot call and I pass that PID, I'm going to expect this thing to block my process that I'm calling it from for 2 seconds while it sleeps and says call done. So I can't do anything here until it's done and says call done, and now my process is released back to me. But if I do the same thing with cast, I can still do things until cast is done and returns cast done in 4.5 seconds. So what I can do is I can send multiple messages to the gen server, so I can go cast, and then I can go call, and call is going to block, but cast is not. So call is going to come back once cast is, or it's going to time out. But if it didn't time out, which is really bad for this demo, you'd be able to see that one happens after the other. So let's go cast, and then we'll call in a little bit. So hopefully we don't block this thing for 5 seconds. So I can pass this thing several messages, and it's going to handle one synchronously and one asynchronously, depending on if we're calling or if we're casting to the gen server. So now that we've seen this, like, what are gen servers actually good for? Well, they're good anytime you need to manage state or need concurrency and isolation. So some examples, pretty basic ones, like if you're making HTTP requests to an external service, you don't know how long this is going to take. You don't know if you're going to get a success back or a failure. And you don't want to block your application while you wait for this thing. You can just wrap this implementation in a gen server and just cast this. And that way, this process goes, deals with the HTTP request, and then once it's done, it returns you its results. And while it's doing that, your main process is still available to work on other things. Other good examples are things like real-time collaboration. So like one of the most common intro to gen server examples is an auction manager. I think I've probably done like 4 or 5 different live coding technical interview questions, which is make me an auction gen server. It's also like in the intro to one of the Elixir textbooks. So it's a pretty good use case of this. So you can store like the current bid. You can handle incoming bids in a temporal fashion. You can count down the time left in the auction all at once. So you've got this gen server, which is going to handle all of this for you. And I think next time we'll talk about supervision, name registration, and we'll build an actual auction app using all of these concepts so we can see how it actually works in real setting. And if we have enough time, maybe we can hook it up to like a live view page and get everyone in here to start bidding on something so we can see how this thing works. But yeah, this is the intro to GenServers. So thank you. Any questions?
So under the hood, it's the same code as you showed initially. It's like used so often that like people decided, okay, like we'll call it GenServer because like everything like following the same pattern, and you don't need to like create like.
Exactly. Yeah. It literally stands for generic server, because this is like a pretty generic implementation of a loop that maintains a state and does work. Exactly. And so instead of being required to write all this recursion and manage the state and manage the communication, you're now given this generic API which handles all that for you, and then you just figure out what you're going to do with that state.
See the example you've got on the screen here. I don't quite understand. So in your fake gen server, you're sending a message back to the calling process, like on that send call, you're popping something off.
Yep.
And then it's sending it back to the calling process. What made it show up, like show a second item there? Does send actually receive messages?
Yeah, okay, so this is my implementation of pop,
Right.
where I pop the item off the list and then I send it back to the caller.
Right, what received it and printed it out on the screen for the...
So my process, the process that I'm calling it from. So everything in Elixir is a process, even your like shell, your terminal is a process. So this process sent a message to that going, hey, give me the item off the list, and this sends it back to my process here. And in order to get it from the mailbox, we had to call this flush function.
Oh.
Yeah.
Flush took the pending messages because nothing received them yet, and then just...
Yeah, it took the messages off of my mail, or off of my queue, because I don't have a receive block defined here. If I had a receive block defined here, I wouldn't have to do this, but this just takes it out. And
You basically can replace flush with like receive and the show with
Yep.
what you receive. Like,
Cool.
awesome. Thank you, guys.
Thank you.
is there a question?
Well, I was just curious. You mentioned earlier that calculator example, you wouldn't do it in production.
Mhm.
And maybe it's too advanced, but I was curious if you just like touch on what about that was not production worthy.
I don't remember what the documentation said, but I can pull it up right now and we can see.
The main thing is like with GenServer, you probably want to be doing some type of like async or concurrent sort of thing, and like that would just be too much overhead.
I think if I remember correctly, what it was saying is like, the documentation says that a GenServer is nice, but you don't need to reach out to it for every little thing. And something like a calculator doesn't actually need to persist a state, whereas you can like pass it the previous value. So it's overkill for it. And it's also like a bit of a code smell because now you're organizing business logic into a GenServer, which you like kind of shouldn't do. But it makes for a very good example of like how cast and call work.
Mechanics.
Gotcha. Yeah, it just should
Yeah.
be more like process.
Yeah.
This is another kind of rookie mistake in a sense, which a lot of people have to go through, is with Elixir, like, because if you're coming from a language that makes threads hard, and then everybody says threads are hard, and then with Elixir where you just like, as many threads as you want, everybody gets threads, and then you're really tempted to be like, oh, that's a faster way to get things done. But this, the reality is, no, it's not a faster way to get things done. It's just like gonna cause yourself more headaches. And so that probably also is part of it, is that you don't necessarily want to give like a simple calculation, like its own process and like, you know.
Gotcha. Cool.
You can repeat like two leaking threads or like leaking servers. So if you
I don't know that it would,
if you like lose the feeds and you like it will be running forever, but like will be unreachable.
well, normally you would have it under some sort of hierarchy or something,
yeah.
either supervision.
But yeah, if you don't bind the PID or register that server, like you can lose it and then it's going to be running forever.
I've got a friend who's writing a MUD. I don't know how many of you are old enough to remember MUDs. Multi-user dungeon, so a command line MMO. And he's turned everything in it, including items, monsters, everything is a process. And it's a GenServer. And the performance is fine. But your ability to track anything that system is zero. It is impossible because everything is happening asynchronously, and you have no sense of what order things are happening in. So it's the more you get, the more you lose that ability to visualize what's happening. And you get this very exciting mess of messages flying all over the
It is
place.
exciting.
And then if you're like, he and I, we tried to put together an application to actually be able to visualize the messages going through there, but that turned into another bigger project even than that. So yeah, it's very tempting to do that, and it's kind of cool that you can. But if you're writing that code in production and then you're leaving the company and somebody else is going to take it over, they will hunt you down and murder you.
And even something as simple as like writing unit tests for a system like that is going to be impossible.
But despite its advantages, it's performant and stable.
Yes, oh yeah.
So
And it's
there's something
cool.
to gain.
The other thing to be aware of if you're using a ton of processes is the testing becomes more difficult, and you're kind of like introducing race conditions into your tests, and so you're complicating your life, put it that way. Complicating your life unnecessarily, and if you don't need to complicate your life, then don't. So you want to like wrap processes around things that kind of are doing their own thing, and a calculation doesn't fall into that category, in my opinion.
Yeah, I think in the last like 3 years, I can count on one hand how many GenServers I've actually written. So it's when you start an Elixir, you're like, oh, this is sweet. I want to do it all the time, kind of like Kevin mentioned. And then once you get writing production systems, like probably not going to use it that much. I mean, depending what you're doing. Like if you're making like a web app or like a CRUD app, probably not for much. So
Once you get into it, you'll get a feel for like, oh, this feels like a GenServer, or this feels like it shouldn't be a GenServer. So like, I don't really cover this in my talk, but like when Claude was programming the thing for me using the live coding thing, it resorted to GenServer sort of like by default because it was repeating a pattern. But if you're writing a module that's effectively like a bag of functions, it's not a GenServer. So just understand whether you're writing a bag of functions or whether you're writing like a thing that needs to kind of track on its own.
cool. Well, thank you guys. Jeff's up next.